Thank you, everyone, again. Thanks for having me. Tonight, I want to talk to you about GraphQL subscriptions in Django. I am a JavaScript developer in Italy. I love Django. I love unit functional tests. And I love also writing about technology and Django and JavaScript. Most of my work these days is for 20Tab. We are a Django agency in Rome, and we build digital products with Django, React, and Next.js. Let's jump right into the topic. The plan for this talk, we will talk about adding GraphQL subscriptions to our Django project and what it takes to work asynchronously with the Django ORM. To start off, this is how you can configure Ariadne and channels into your Django project. Now, the goal of this talk is to show you how to use Ariadne, which is a GraphQL library for Python with an integration for Django and other Python frameworks, and channels, which is a layer around Django which adds supports for WebSockets to Django. This is a sample from the settings.py from this demo Django project. We have an order app, which is as a simple model loaded, and we loaded Ariadne too, and channels. Both library must be installed into the project. We also need to configure the ASCII application so that it will load it by the ASCII server. Once we configure the project, we need to think about routing. This is how you say to channel how to load your ASCII applications, because for channels, every route that you declare inside your URL router, for example, is a single ASCII application. In this example, we have two ASCII applications. The first application is the GraphQL layer around WebSockets and HTTP, which is in charge for loading the schema that we will see in a moment. Next up, we have also a route path, which is in charge for serving any other view that Django has loaded, for example, the admin or the home page or any other view, really. This project shows how to dip your toes into GraphQL for Django. I am imagining that you maybe have already a Django project in place and you want to integrate step-by-step GraphQL into your project. To do so, you can live side-by-side your views and add, in addition, another GraphQL view which will serve your schema, your subscriptions, and your queries. This is an example of the ascii.py file. And here we load the schema, which we'll see again in a moment from the order application. And we declare an URL router, which will serve both the GraphQL endpoint and any other view that the application has already in place. So URL router is how you say to Django channels, load these ASCII applications and make the user happy. Once you configure the routing, you need to wire up a minimal schema. Now, this schema is simple on purpose. It is just for showing you all the building pieces. We have an enum, which declares the state for a sample model, which is order. And we also used a scalar date type from Ariadne, which is later loaded in the executable schema. And here we have a user type, an order type, which is connected to, the user is connected to each order. And we also declare a query. We won't use the query in this simple application, but the query must be declared because Ariadne wants it to load all the schema. And we have the subscription here, which will give us, in this example, just the last order that a user placed in the system. So this is how you declare a subscription in the schema here in GraphQL. Now, I want to stress that I'm not a backend developer, but I can work my way out with Django, and I enjoy building stuff with it. And this talk is a tale of my adventure while integrating GraphQL Ariadne subscriptions into Django. With the schema in place, we go where the real meat is. Now, this is the schema.py file from my orders application. I took out the schema for brevity because it would fit in this slide. In brief, we load a subscription type for Ariadne. And to fulfill a subscription in Ariadne, we need two functions. The first function is a generator function, which is in charge for loading the actual data from the database. Now, if you're familiar with the generator function concept in JavaScript, a generator function is a function that can be resumed and stopped at will. And an asynchronous generator function, which is the function that we need here, instead is a generator function which returns to the outside a generator object, which you can basically consume from the outside with an asynchronous iterator. The concept maps almost one-to-one with the JavaScript concept of a generator function and asynchronous generator functions. Now, keep in mind that this example is just for demo purpose, so it is nothing that I would suggest using production, but it is enough to show the concept. In this generator function, we load the data from the database. And what stands out here is that while in an asynchronous generator function, we cannot directly access the Django ORM like that. Because at the time of this talk, the Django ORM is still synchronous, so you cannot use it in an asynchronous context unless doing a small trick that we'll see in a moment. So we have this asynchronous generator function, which gets data from database, and we need also a resolver, which can talk to Ariadne and give back the data to the client. So we need these two functions. And once we get we define these two functions, we pass the schema, the scalar that we used in the schema, and the subscription to the make executable schema function. I omitted the query here for brevity. Now, what happens if we try to use this code in our Django project? We get this scary error. You cannot call this from an async context. Use a thread or sync to async. As I said before, the Django ORM is synchronous to this day, but there is work in progress for adding the asynchronous layer to the ORM. In the meantime, we need to use an adapter in order to talk from an asynchronous context to the Django ORM. How do you do this? If you want to try out this subscription in the playground, you will see that even with the GraphQL debug turned to false, you will see this error in the playground. How do you make the Django ORM work inside an asynchronous context? While working with channels, we can use this function, database sync to async, which is a small wrapper around sync to async from ASCII ref. So If you, for example, if you deploy a Django project under an ASCII server and you're not using channel, you can use sync to async from ASCII ref. If you use channels, you can use this adapter, which also closes any connection when the connection gets when the connection is closed by the client. And this is the first step in making the Django RM work with within an asynchronous generator. We have this function, database sync to async, which wraps the ORM access. Here, for this demo, I am returning the last order created in the database at any given time from a user which is buying something in our shop, in our fictional shop. And you call this function by passing in another function. I used a lambda function here for brevity, and you call this database sync to async. The result of this call is the actual data that is fetched from database. And this is the data that you pass to the resolver, that Ariadne passes to the resolver. This is the subscription that you can fulfill with the machinery that we saw before. So you need an asynchronous generator function and a resolver. Now, things look simple if we fetch just the outer layer of the field of this model. What happens if we want to fetch also the user which is connected to this order? And we have a foreign key relationship here. Again, we will get this. You cannot call this from async context, blah blah blah, because we are trying to access the foreign key, but Django won't evaluate this foreign key immediately. So that will be evaluated in a synchronous context, not in an asynchronous context. And to make this work, we can use select related, which forces the evaluation of the foreign key relationship inside the asynchronous context. And here again, we have database sync to async, we have a lambda function, and we get the last order from the database by issuing also just a slightly bigger query to fetch also the related user. And this will make the subscription work. So here's the subscription that we requested to the server, and here's the response with fake data, of course. And we get the state of the order, the date of the order, and the date is handled nicely by Ariadne with the dates color, which is a nice utility for working with date field in Django. And we also have the user with a username and the email. Usually, depending on the decoupling style that you put your Django project in, we might have a JavaScript front-end that is loaded by a Django template. This is a common pattern for decoupling Django application. But most of the time, you will have a Django application living on a different origin from the front-end. And for make it work cross-origin resource sharing with the GraphQL endpoint, since channels builds on top on Starlet, and Starlet is already included when you install channels, you can use this synchronous course middleware. So you can wrap your GraphQL layer inside this course middleware, and you declare what origins you need to allow. Of course, the star is idly described in production. This is for development only. But you need to pay attention to allow all the methods in order to send also the options. The first option, the option request, the pre-flight request that the front end needs to send first of all, and the other part remains untouched. Loads any Django view that you already have in the project. How to use GraphQL subscriptions in the front end. There are many competing GraphQL libraries, but I enjoy using Apple GraphQL. And in that case, you have to pay attention to use both the HTTP link and the WebSocket link. Otherwise, any GraphQL query will travel over WebSockets, which is not what you want. You need to instantiate both the HTTP link and the WebSocket link, configure the client to use a split link function, which forwards the right link depending on the protocol of the request. And that way you will use GraphQL queries over HTTP. And as soon as the subscriptions gets activated, you will use the WebSocket link. Historically, to have persistent WebSockets, we needed to employ weird tricks in the front end. With Apple GraphQL, you can just declare these options, reconnect to, and the client will try to reconnect to the backend if the backend goes offline. Lastly, you can use the use subscription hook if you're writing a modern React application based on hooks. It's everything for this talk. Thank you very much. If you have any question, I will be happy to reply. And I also wrote a little tutorial about these channels and Ariadne adventure. And I just published a book about Django and JavaScript frontends. And this has been reviewed by your Marcin. Thank you very much for being my technical reviewer. Thank you.
Okay, great. That was really great. GraphQL subscriptions are little known and sometimes frightening topic in a GraphQL community. So thank you for this thorough presentation. I just have a question. Do you feel that subscriptions are really production ready in GraphQL world, and do you see any shortcomings that we should be wary of when choosing to use them instead of alternative solutions?
I think WebSockets are not a straightforward topic. So while on HTTP with REST APIs, everything is battle tested these days. WebSockets are a bit tricky sometimes, and GraphQL complicates a bit the scenario. But I feel that with Apollo client and the work that the community is doing with Ariadne makes this pattern really production ready.
Okay, thank you very much. That's nice to hear. I like subscriptions. I would like to see them more. Okay, thank you, Valentino. That was really great presentation.
Thank you.